Hello, my name is Kai and I will guide you in today's lesson. In this lesson, we will explore the activities for the air pressure sensor. The air pressure sensor can be used to measure temperature and atmospheric pressure accurately. As the atmospheric pressure changes depending on the altitude, it can also measure the approximate altitude of a location. The air pressure module has a digital output and makes use of the I2C communication protocol, which is supported by the Arduino. The module sends out data through the pins VCC, GND, SDA or the data line that is responsible for the transfer of data, and the SCL or the clock line that is responsible for synchronization. Note that these modules are already internally connected to the Grove base shield. You do not need to use the Grove connectors when you have not broken the modules out of the board. I am only presenting to you how to connect the modules on the shield, assuming that the modules have been broken out from the Arduino Sensor Kit Base. For our first activity, just connect the air pressure sensor to the I2C pins. Once it's all connected, attach the shield to your Arduino Uno and connect it to your computer. In order to use the air pressure sensor, we need to include the Arduino Sensor Kit library. Next, we're going to make float variables for the pressure, temperature, and altitude values. On the setup function, we turn on the air pressure sensor by typing in pressure.begin. And in order for us to use the serial monitor, we type in serial.begin with the 9600 baud rate. Then on the loop function, we identify the pressure, temperature, and altitude values by typing in pressure.read pressure, pressure.read temperature, and pressure.read altitude. Then in order for us to view these values on the serial monitor, we type in serial.print. Then finally, add a 1-second delay. Once done, click on Upload and it will automatically compile and upload to your board. Once it's done uploading, you can now open the serial monitor and view the temperature, pressure, and altitude values. For the next variation, we're going to add a buzzer in our project. Just connect the buzzer to D5. We're going to add a buzzer to our project. In order to do this, we have to define the buzzer as pin 5. Then on the setup function, we indicate the buzzer as an output. Then on the loop function, we're going to add an if statement before the delay. In this project, I want the buzzer to turn on if the temperature has reached 30 or beyond. And will turn off if it doesn't reach that value. Once done, click on Upload and it will automatically compile and upload to your board. Once it's done uploading, you can open the serial monitor and observe that if the temperature has reached 30 or beyond, the buzzer will turn on. Now for our final variation, we're going to add an LED into our project. Connect the LED to D6. We need to define the LED as pin 6. Then on the setup function, we have to set the LED as an output. Then on the loop function, we add another if-else statement that will activate the LED if the temperature has reached greater than or equal to 28 degrees Celsius. Once done, click on Upload and it will automatically compile and upload to your board. Once it's done uploading, you can now open your serial monitor and observe the temperature, pressure, and altitude values.
Now that is it for this lesson. To learn more about the other modules, simply head on to the next video.